Hello and welcome to the Spring 2021 Senior Design 2 Expo. We are your PCE Mold Senior Design 2 team. Our team's objective was to design and build a device that can safely and securely lift and lower a mold weighing at most 500 pounds, transport it at least 100 feet, and insert or extract molds of various weights and sizes into and out of each injection molding machine. This must be done without causing damage to the operator, machines, molds, or surroundings.
The prototype was required to be safe to operate by one person, lift and maneuver 500 pounds, work with all three machines at the Polymer Center of Excellence, accommodate various mold sizes, accurately position the molds in the machines, and not cause damage to the machines, molds, surroundings, or operator.
The prototype consists of a boom arm, winch, trolley, headbox, column, and cart. The boom arm is a 6-foot-long I-beam bolted to the headbox. The trolley rides along the I-beam, and the electric winch is vertically mounted to the trolley and operated via remote control. Power is supplied to the winch by a battery positioned near the rear of the cart. The headbox is made of welded steel plate. It houses a bearing and bushing to allow for smooth rotation around the column. The steel rollers at the bottom mate to the column and support moment loads. The column is an 8-inch pipe with a circular plate and pin welded to the top to allow for headbox rotation. It is bolted to the cart, which consists of steel box beams with a plywood cover. A handle and the counterweight box are located at the rear.
Traditional saw cutting and water jet cutting processes were used to produce component geometries from steel pipe, plate, and bar stock materials. Very little machining was required beyond rough cuts. A bearing was press fit into 1-inch bar, and the circular top plate and pin were machined and pressed together to ensure good fitment, weldability, and rotational freedom of the headbox assembly. Welding was the primary means of joining components. Structural welds were used at all intersections of the column and cart, and the headbox has mainly structural welds with light welds and low force members.
Initial testing of pushing force found that the cart required too much input force for a single individual to operate on carpeted flooring. The problem was rooted in differences between sustained and initial pushing force. Data was collected and the solution was to increase the wheel diameter and use a harder wheel material.
To verify the prototype's performance, the full assembly was incrementally loaded up to 385 pounds. A mold change was completed, and the cart was maneuvered to each key location at full weight. This verified PPS requirement to build an apparatus for a single operator to exchange and transport molds from the machine to storage.
Some improvements for future implementation are cart weight reduction, motorized pushing assistance, and aesthetic improvements.